Bismillahirrahmanirrahim. Welcome to Rahman Digital Production. Today we are going to talk about the acceleration. First we talked about the speed. Rate of change of speed is called velocity. Then we talked about the velocity, that is rate of change of speed. Rate of change of distance is called speed. Rate of change of displacement is called velocity. Now rate of change of velocity is called acceleration. uh, Rate of change of velocity is called acceleration. Remember that if velocity is changing, then we are representing it by delta v. So mathematically we can write that A is equal to, because this is a vector quantity, so you have to put an arrow head on it, delta v divided by delta t, and delta v minus u divided by t, we can technically write it, where v is the final velocity and u is the initial velocity. Because there will be change in the velocity, so there must be final velocity and initial velocity. We have to change the initial velocity from the final velocity. We have to change the final and initial from one another. So that will call acceleration if there is a change in the velocity. Remember, ladies and gentlemen, there are two types of velocities. There are two types of velocities. Number one is called linear, of acceleration. There are two types of accelerations. Number one is linear acceleration, and the second one is called angular acceleration. Angular acceleration. So velocity is a vector quantity. So vector is having magnitude as well as direction. If there is a change in the magnitude and not in the direction, then this is called linear acceleration. And if there is no change in the magnitude of an object and there is a change in direction, for example, you are whirling a stone attached to a string and you are whirling it, so at every position there will be a change in, here it will be in this direction, here it will be in this direction, and here it will be in this direction. At every position the direction is changing if it is with the constant velocity, yani there is no change in the accelerate in the magnitude, so that is called then angular acceleration. We are particularly talking about the linear acceleration, not about the angular acceleration. In A level you have angular acceleration in O level you are having only the linear acceleration. Okay, if the magnitude is increasing, then it means that acceleration is increasing. If the magnitude is decreasing, then it means that the acceleration is decreasing, and the decrease in acceleration is also known as retardation or negative acceleration. Retardation and negative accelerations are the two other names given to the retardation or negative acceleration when the acceleration is increasing. Sorry, decreasing. If the velocity is decreasing, it is called retardation or negative acceleration. Ladies and gentlemen, the SI unit of acceleration is the SI unit of acceleration is meter per second square. That's the whole story about the acceleration, the initial. Now we are studying the velocity time graph, which is very important topic. Velocity time graph. Velocity time graph. Ladies and gentlemen, you can see that uh, velocity and time. Time is on the x-axis and velocity is on the y-axis. There are two graphs inside that. Number one is this area. We have to talk about this area first. And then there is a second graph of straight line. You can see that the time is elapsing, but there is no change in the velocity. 20 meter per second is the velocity, because all these values are positive, so it means that it is moving in one direction. So we can see that there is a constant velocity, constant acceleration. And in the second graph, that is known as uniform acceleration. Uniformly it is accelerating, but here it is constantly. Remember, ladies and gentlemen, as we discussed that acceleration is equal to delta V divided by T. So, here we are saying that the change is not there. It is always 20 meter per second. And the time is in 1 second, 20 meter distance velocity is covered in second, third and fourth. So it is moving with the constant velocity. In this particular case, as the velocity remains the same, as the time is increasing from 1 second, 2 second, 3 second, 4 second and 5 second, but the velocity remains constant. It means that the object is moving with the constant velocity. Now, the second information which we can get from this graph is, since velocity is equal to linear distance divided by time. So if we want to find the linear distance, then linear distance is equal to velocity multiplied by time. The velocity of this is 20 meter per second and the time is 5 seconds. So it means 20 multiplied by 5, and one is meter per second and the second one is second, this one. So this second will be cancelled with this, and 25, it means that this body has covered a distance, linear distance of 100 meter in 5 seconds. Ladies and gentlemen, in if we want to find the distance covered, so we can find it the area under the graph, because this is a rectangle. So in second way, if we want to find area of rectangle is equal to length multiplied by breadth. Length multiplied by breadth. Length is 5 and breadth is 20. So again it is 100 meter. So in this case and in this case, both the answers are the same. So in this way we can find the distance. Now we are turning our focus to the second. This is graph number 2 and this was graph number 1. Remember that the gradient of velocity time graph give us acceleration. The gradient is giving us acceleration. There is a constant velocity here because the line is a straight line, so it means that there is an increase in the velocity with the passage of time. So it means that there is acceleration, but the acceleration in this particular case is constant. The acceleration in this particular case is uniform. Sorry, it is uniform. Now, ladies and gentlemen, if we want to find the area under the graph, so we will find that how much distance this object has covered. Now, you can see that this is a triangle. This is a triangle. So, area of triangle is equal to 1 over 2 into height into uh, breadth. So we are writing 1 over 2 into the height of this is 50. You can see it from the graph that this one is the height of this rectangle is 50 and the breadth of this is 5. So this is 5. Now 2 ones are and 2 25s are and 25 fives are. There is 125 meter square. This much area is covered by this. Here also we have to write square because this is area, and area is all. But if you are considering, you want to see that how much distance it covered, then it is 100 meter, and here it is 100 meter square is the area. So the area under graph is called distance, that how much distance it covered. So both of them are the same. So in this particular case, area this triangle covered is because we have to find the area of this triangle. We found it, and that comes out to be 125 meters square. So it means that this body covered 125 meter. Okay, now we are talking about, that was a straight line, one was constant, the second was uniform increase. Now we are talking about the graph number third. Ladies and gentlemen, if at any point you want to find the acceleration or velocity, then you have to draw a tangent line at that point and convert that into a right angle triangle. This is important, that this should be a right angle triangle. So we are saying that because this is parallel to x-axis, we are calling it delta t. And because this is parallel to y-axis, and y-axis represents velocity, so we are calling it at that particular time there is a delta v1. Now at point B, we have to draw a tangent line and make a right angle triangle of this. So there are two types of triangle. One is the smaller one and one is the larger one. Remember, ladies and gentlemen, that if it if the triangle is smaller one, there is a small change in the velocity. If the triangle is larger one, then it means that there is a greater change in the velocity. So between the point A and B, for equal interval of time, delta V2 is larger than delta V1. So we are facing acceleration because delta V2 is greater than delta V1 and the time interval is the same. We are not writing delta t here because there is no change in the time. I told you that for equal interval of time, delta V1 and delta V2 are different. How? Because there is smaller triangle and there is larger triangle. So it means that if there is a change in the velocity, we represented V1 and V2. So there is an acceleration. Remember, ladies and gentlemen, that if this velocity was equal to this velocity, very important point, then we would not write V1 and V2. V1 means one type of velocity. V2 means second type of velocity, not the same. If it was the same, then we could write it delta V and delta V. There is no change in the velocity. If there is no change in the velocity, there is no acceleration then. But because in this case there is a change in the velocity, so between the point A and B, we are observing that the acceleration is increasing, not decreasing. We will observe that in this case the acceleration is decreasing, but in this case the acceleration is increasing. So remember these points in the graph, that for equal interval of time, delta v1 is different than delta v2. So it means there is a change in velocity, and when there is a change in the velocity, according to the definition, we are having acceleration. Now we are turning our focus to graph number 4. This is graph number 4. It is written, for equal interval of time, if we consider point C and point D, you can see that at point C, because it is steeper and it is in positive direction, it is moving in one direction, it means that this triangle is larger than this triangle. So it means here the velocity dv3 was greater, and at point D the velocity d delta v4 is smaller. Again we label it with 3 and 4, so it means there is a change in velocity. It means that we are having the acceleration here. Here the acceleration was increasing from smaller to larger, but here the acceleration is decreasing from larger to the smaller triangle. Decrease in acceleration is called retardation or negative acceleration, as well as we can observe that in this particular line. Now at point E, the velocity stops increasing or decreasing. From this point onward, this object is moving with the constant velocity, as it was in this case, neither increasing nor decreasing. Here it is increasing, but here it is decreasing, and then when it reached to point E, from the graph we can observe that at E there is a straight line, so it means that it is neither increasing nor decreasing. Ladies and gentlemen, one thing you have to keep in mind, that if we want to find the distance covered by this object, so we can find the area under the graph. For example, we said that this is meter square, but we have to say that area is 20 meter square, 100 meter square. So it means that 100 meter, whatever the area comes out to be, then it means that we have covered this distance. Now, very important topic, you will be tested in the CIE exam by giving these sort of graphs. If this is velocity and this is the time, and the body is moving on the x-axis, it means that the body is at rest. Body is at rest. Now, if the graph is like this is the time and this is the velocity, and the graph is like this, don't confuse yourself that this is also a straight line parallel to the x-axis, and this is also a straight line parallel to the x-axis. This is saying body is at rest. This will also confer that this is also, no, it is not at rest. It is moving with the constant velocity. Constant velocity. If the motion of the object is overlapping, very important point, overlapping the x-axis, then it is at rest. Time is elapsing, but there is no velocity change. Magnitude is not changing. It is 0, 0, 0, 0 at every time interval. So it means that it is at rest. But just like in this case, it is 20 meter per second is the velocity. So this is with the constant velocity. This is at rest. Now, if there is a third type of graph given to you, and that is time and that is velocity, and the graph is like this, so it means that this is called the velocity is increasing, so it means the acceleration is also increasing. The velocity is increasing with respect to time, so it means there is an acceleration. Velocity increases, and you can see that from here that it is increasing. If it is like going horizontally to the x-axis, no increase, but here it is increased, it is uniformly. So this is called positive acceleration because the gradient is positive. The gradient is positive, so positive acceleration is there. Positive acceleration is there. If they given you another type of graph and that is like this is velocity and this is time, because the gradient is negative, this is positive and this is negative, so it means that it is also having that the velocity is decreasing, so acceleration is also decreasing. So this is called negative acceleration. Ladies and gentlemen, let me point out one thing. Is it possible that the velocity is in one direction and acceleration is in another direction? What do you think? That if acceleration is on this side, can the velocity be on this side? Yeah, the velocity is on this side and the acceleration is on the, yes, it is absolutely possible. When the car is moving in one direction and you apply the brakes, then it means that direction is that side, but because acceleration is reducing, that is called negative acceleration. So acceleration will be on the other side, the velocity will be on other side, and the acceleration will be on the other side. So in this case, this acceleration is decreasing. Now in this case, if the graph is like this is velocity and this is time, this is velocity and this is time, so it means velocity is increasing, acceleration is increasing. But in this case, if it is like this, that what is this? Velocity is increasing, the acceleration is decreasing. Then if you can see, velocity is increasing and then the acceleration, because there is a change in velocity. Here also you are feeling like this, that there is a change in velocity. In this case, you are also observing that there is a change in velocity. So in velocity, in this case, increasing with the time, acceleration decrease with the time. Velocity increasing with the time, acceleration is also increasing. Remember that when you are pressing the acceleration pedal in the car, it means that you are giving it acceleration. It is moving fast. Okay, there is very important topic tomorrow we will discuss, because we have to find the area under the graph. We will do two different question. We will observe two different scenarios, so don't miss, because that is the most important one tomorrow. So that's it for today. If you people haven't yet subscribed, please subscribe my channel and share it with your friends and family members, so that you are supporting me to continue these lectures. Thank you very much for watching. Have a nice time. Allah Hafiz.